Hello everyone, this is the first lesson recording for IM2, May 6, 2021. Starting with announcements, next Thursday you're going to have the final unit test. It's going to cover polygons and circles. The polygons such as the area of different sided polygons and the angles, interior, exterior, the missing angle measure and so on, and area scale factor. Circles including area, sector area, circumference, arc length, and arc measures, and inscribed angles and central angles. Something else, after the finals, we do have our final exam schedule now. And for period 1 and 2, IM2, it's going to be happening on June 1st. So Monday is a public holiday because it's a Memorial Day weekend. And then June 1st will be when you will have your period 1 to final exam, and Wednesday and Thursday will be your other classes, and then Thursday is the last day of school. All right, let's get back to our circles. Where have we been? Well, we've looked at that circles. What is the definition of circle? When you have a center point, and circles represent all collection of all the points that are equidistant from the center point. So in this case, 4 units long. The radius is 4. Okay, so any point along the red means that is 4 units away from the center. That's the definition of circle. So what do we know so far? We know the relationship between area, circumference, radius, and diameter. We also know the relationship of central angles to sector and to arc and to inscribed angles. Such as if you have the central angle of 80 degrees, then what do we know about the angle measure of this inscribed angle? It's going to be half of the central angle. So this is going to be 30 degrees. Okay, so now we're going to be moving on to a new topic, circles on a corner plane. So we know what a circle is. What if we bring that into a corner plane? Well, what's that going to help us? We can get information such as radius and center point, and then come up with equations. So how can I write an equation that represents all the points on the circle? Just like you can write an equation of a straight line or equation of a parabola, but this time we can figure out the equation of a circle. And to explore that, you are going to be working on card number 1 to 3 of Desmos. Here we go. Okay, which Darth Vader are you today? I'm feeling happy, carefree, relaxed, confused, content, stressed, peaceful, sleepy, or cheerful. Okay, click on one of the Darth Vader to indicate how you're feeling today. And if you like, you can say more about the responses below. Number 2, find the center and radius of the circle. Where is the center point? How would you figure out where the center is? Center is going to be straight back in the middle, right? How can you figure out middle? Well, what you can do is you can try to draw a line that is the widest point. Okay, widest point will be at this level, right? So I could draw a straight line looking like this. And what about vertically? Which is the widest part? I would say this it would be the widest part. Okay, if that is the case, where the both vertical and the horizontal intersect, that's going to be the center, because that's the joining of the two widest parts. Okay, and so in this case, what is the center here? What is the coordinate? Remember, coordinate is always x comma y. What is the coordinate of this? X coordinate of this, it's 0 comma 2. So I am going to type in 0 comma 2. And the radius, how do I figure out the radius? It's the distance from the center to any point. Well, it's going to be much easier to figure out distance from by going horizontal as opposed to diagonal, right? So because this is really easy. So count 1, 2, 3, 4, 5. So the radius is going to be 5. Okay, sketch the circle with the center 3, comma, -4 and radius 6. And when you're done, click check my work. So let's just try that. I find my 3, comma, -4. Where is 3? That's my x coordinate, comma, -4 is right there. So this is going to be my center. Okay, and I'm looking for radius of 6. That means I need to go 6 units in all directions. So I can go, let me get a different color, and I can go 1, 2, 3, 4, 5, 6. So this is going to be my new point on the right, and then I can do the same thing in the other direction. So this is another point, and you can do it vertically as well. 1, 2, 3, 4, 5, 6. Or if you know the coordinate of the center, I can also add that number as well. So -4 plus 6 is going to be -10, which will be right here. Okay, now I have sort of 4 points. I can try to draw the circle connecting those points in a nice sort of circle looking shape. Okay, that's my best circle. Not great, but at least I tried. And then I can check my work and it draws it for you. And I was on the right spot. My drawing was not great though. Next up, you're going to be working on card number 4 to 6, identifying center and radius and sketching it, and then looking for patterns of circle equations from card number 7 to 10. Okay, so card number 4, we need to find the coordinate of the center point. Again, I look for the widest horizontal part and the widest vertical part. That will be, this will be the widest part of the circle. Vertically, this will be the widest part of the circle. Okay, so that means that the center point is right there, isn't it? Okay, so where it crosses. So the center point is right there. What is the coordinate? That's going to be 1, comma, -4. And then from here, what is the radius? I find the horizontal distance from the center. Okay, that's 4 units away. So my radius is 4 units. Okay, now this time you sketch a circle with a center 3, 0 and radius of 4. So 3, 0, the x-coordinate is 3 and y-coordinate is 0. So that's my center right there. And I am looking for the radius to be 4 units. So I'm going to go to the right by 4. 1, 2, 3, 4. That's my rightmost point. And 1, 2, 3, 4 here. And then from 0 plus 4 will be here. And 0 minus 4 will be right there. Now I can just join the circle. Let me use a different color. And let's try to make a nicer circle. Well, that's my best. Okay, and check my work. There we go. I was on the right place. It's hard to draw with a pen here. Okay, card number 6. What's the circle center point? Okay, again, I am going to draw my widest line here. Vertically, the widest line will be here. So that means this is my center here. What is the coordinate? -2, 1. And to figure out the radius, I could start counting, Or I could also subtract. Okay, I know that it extends to the x-coordinate of 4 and the center is -2. So 4 plus 2 is 6. So I know that radius is 6. Okay, now we're going to go on to card number 7 to 10 to look for patterns of circle equations. And now below is the equation for the circle on the left. Experiment how the circle is affected by changing 16 to different number. So if this is x squared plus y squared is 16. If I change this 16 to say 10, what happens? Okay, the red was the original. We've just created a smaller circle. Okay, what if I made this into bigger number like 25? Okay, the red was original. Now we've created a bigger circle. Okay, what if I made it bigger? Okay, like 36. Okay, it got bigger and bigger and bigger, right? I can make it 50 and there's bigger. So the bigger the number on the right hand side, it seems to make the circle much bigger. So I'm going to go to 100. Okay, so that's going to be much bigger. Okay, what is, so it's when we're talking about circle being bigger, what is determining the circle's size? It's really the radius, right? And you can see that what is the radius in this case? Radius, it extends all the way to 10. Do you see a relationship between 100 and 10? Or if I change, originally it was 25. What was the radius? Oh no, it wasn't 25, it was 16 before. What was the radius? In the blue, it's 1, 2, 3, 4, 5. 5 was the radius, and when this number was 25, 5 was the radius. When this number was 100, the radius was 10. Do you see what the relationship? Okay, it certainly relates to the radius, and you can explain what you think. Okay, what would be the equation of the circle on the left? So, looking at this, this was x squared plus y squared is 25. So, and that 25 determined how big the radius was. So if it was, this was 25, square root of 25 is 5, and so the radius was 5. So in this case, what is the radius? Radius is 10. So we experimented with this. So it's going to be x squared plus y squared is equal to, because I count my radius to be 10 units away in all direction and the center is 0, 0. So my equation is x squared plus y squared is equal to 100 because the previous card had the center as the 0, 0 as well. So the only thing I'm going to change from this circle to the next circle is the size of the radius, which from 16, I'm going to change that to 100. All right, now change the 6 and see how the circle is affected. Okay, so if I change this 6, I can make this, say, 4. What happens? I've just moved the center of the circle. If I make this 1, what happens? It moves it farther. What if I make it bigger? Oh, it moves it to the right. So depending on how big the number is, it seems to affect the horizontal position of the center. Okay, so it relates to circle's horizontal position. And when that number was -10 here, where was the center? Center was 10, 0. Okay, if I change this to say 2, x minus 2, the center in this case, where is the center of this triangle? It's 2, 0. What if I change this number to plus?